Hello everyone. Welcome to the Building Services Subject Lecture. Myself Vinod Shivkumar, working as an assistant professor in the Department of Civil Engineering at KPR Institute of Engineering and Technology Coimbatore. Unit 5 Green Building. We will explore the following topics: concept of green buildings, components of green building, advantages and applications, utility of solar energy in buildings, day lighting, building energy analysis, lighting economics and aesthetics, low energy and passive cooling, green composites for buildings, low energy approaches, water utilization in buildings. What is green building? A green building is a building that, in its design, construction, or operation, reduces or eliminates negative impacts, and can create positive impacts, on our climate and natural environment. Green buildings preserve precious natural resources and improve our quality of life. There are a number of features which can make a building green. These include efficient use of energy, water, and other resources. Use of renewable energy, such as solar energy. Pollution and waste reduction measures, and the enabling of reuse and recycling. Good indoor environmental air quality. Use of materials that are non-toxic, ethical, and sustainable. Consideration of the environment in design, construction, and operation. Consideration of the quality of life of occupants in design, construction, and operation. A design that enables adaptation to a changing environment. Concept of green building. Green building is a whole systems approach for designing and constructing buildings that conserve energy, water, and material resources and are more healthy, safe, and comfortable. Many think of solar panels when they think of green building. Components of green building. A green building has four main elements or components on which it is designed: materials, energy, water, and health to make green building more sustainable. Elements of green building design. Materials for green building. Energy systems in green buildings. Water management in green building. Health components of green building. Factor to considered for green building. The orientation of the building. Solar shading. Building material choices. Building envelope. Window wall ratio, WWR. Structure design efficiency. Efficient lighting. Water efficiency. Renewable energy systems. Waste management. Advantages of green building. Although green buildings were once considered costly, the idea has long been dismissed due to its multiple advantages and provisions to help achieve global results, such as climatic change, amongst others. Below are reasons why you should choose a green building. Cost-effective. Improved health. Increased efficiency. Better environment. Higher market value. Water conservation. Psychologically optimized environment. Preservation of natural environment. Application of green building. Reasonable building layout can significantly reduce the energy consumption during construction use. Building exterior wall insulation can significantly reduce the energy consumption of the building during use. The indoor environment for system control to achieve the purpose of a comprehensive system of energy conservation. Make full use of clean and rich solar energy, natural energy. The reclaimed water system is introduced to make rational exploitation and use of water resources and avoid waste. Application of daylight lighting technology to reduce lighting energy consumption. Why buildings are going solar? Solar energy is freely available, clean, renewable energy source. The per capita energy consumption is going at an alarmingly high rate. The price of energy is also seeing new high figures. Buildings are now constructed keeping energy efficiency in mind. The aim is to minimize energy consumption and use alternative solar energy, which has multiple benefits. Utility of solar energy in buildings. Daylighting is the practice of bringing light into a building interior and distributing it in a way that provides more desirable and better quality illumination than artificial light sources. This reduces the need for electrical light sources, thus cutting down on electricity use and its associated costs and pollution. Studies substantiate that daylighting creates healthier and more stimulating work environments than artificial lighting systems and can increase productivity. Daylighting also provides changes in light intensity, color, and views that help support worker productivity. Daylighting significantly reduces energy consumption and operating costs. Energy used for lighting in buildings can account for 40 to 50% of total energy consumption. Properly designed and implemented daylighting strategies can save 50 to 80% of lighting energy. Greater use of daylighting can also provide advantages for the environment by reducing power demand and the related pollution and waste byproducts from power production. Daylighting requires the correct placement of openings, or apertures, in the building envelope to allow light penetration while providing adequate distribution and diffusion of the light. Daylighting. Daylighting can be a viable, energy-efficient strategy in almost any climate, including traditionally overcast climates such as those found in parts of the Pacific Northwest. The technology can work in all building types as well, including commercial office buildings, most spaces within a school, i.e. classrooms, gymnasiums, media centers, cafeterias and offices, retail stores, hospitals, libraries, warehouses, and maintenance facilities. A viable option for most building types and locations, it is important to consider that the architectural response to daylighting differs by building type, climate, and glare tolerability. Thank you.